Today's lesson objectives, students will use postulates involving points, lines, and planes. So really, this is information that you have learned previously, but now we're officially saying that these are postulates. So the first one, through any 2 points, there exists exactly one line. A line contains at least 2 points. Okay, so those are, the second one is a converse of the first one in essence, that if you have a line, that means you have to have at least 2 points. If you have 2 points, then you have one line. If 2 lines intersect, then their intersection is exactly 1 point. Okay, if 2 lines intersect, then their intersection is exactly 1 point. Through any 3 non-collinear points, there exists exactly 1 plane. And so conversely, a plane contains at least 3 non-collinear points. If 2 points lie in a plane, then the line containing them also lies in the plane. So if I were to draw a little picture to go with that, if you have a plane and it has 2 points in it, then 2 points determine a line, so therefore that line would also have to lie in the plane. And then finally, we know that if 2 planes intersect, then their intersection is a line. So all of that's review. It's just now we're saying that they are officially postulates. Okay, so looking at some examples. For example 1, we're going to state the postulate that is illustrated by the diagram. So if you look at example A, if, and then you're given 2 lines, then you're given 2 lines with a point. So what postulate does that look like that is? If 2 lines intersect, their intersection is exactly 1 point. Okay, looking at B, if, and we have 2 planes, then, so pause the video, write down what you think it is. Pause. Okay, hopefully you figured out if 2 planes intersect, their intersection is a line. If we look at example 2, in example 2 we're going to use the diagram to write examples for the postulates. So letter A says a plane contains at least 3 non-collinear points. So if I look at my diagram, the plane that has points in it is plane P right here. So plane Q isn't going to help me out much, but plane P contains points A, B, and C, which are non-collinear. So that's what I would write. Plane P contains A, B, and C, which are non-collinear. So we're going from the general and then coming up with something more specific. Alright, so looking at example B, if 2 points lie in a plane, then the line containing them lies in the plane. So now for this one, I can see that A and B both lie in line P, in plane P, and then also the line containing them has to lie in that plane as well. So what I would write is that plane P contains A, B, and line AB. So that would be a specific example from the figure which supports that postulate. Okay, you're also going to have to sketch some diagrams based on information that you're given. So let's take a look at these two examples. First, example 3. Okay, we're going to sketch a diagram that shows ray FH, which is perpendicular to segment EG at its midpoint, M. So first I need ray FH. Okay, because the order that the letters are written in, I know F is the end point and H is another point that is on the ray. And it is perpendicular to segment EG. So I'm going to draw another segment perpendicular at its midpoint. So it's not the midpoint of FH necessarily, but it is going to be the midpoint of EG. So here is segment EG. It's perpendicular, and at its midpoint, point M. So I put point M here, and then I need to mark that EM and MG are congruent to each other. Okay, ray FH does not have a midpoint because it's infinite. So rays and lines cannot have midpoints. Only segments can have midpoints. So there's my diagram showing ray FH perpendicular to segment EG at its midpoint M. Okay, now we have a line is perpendicular to a plane if and only if the line intersects the plane in a point and is perpendicular to every line in the plane through that point. Okay, so this is another postulate, and we can draw a picture showing that to be true. So first I'm going to draw my plane. And I want a line that's perpendicular to that plane. And remember, we make it dotted when we can't see it anymore as it goes behind the plane, and then it reappears underneath, so it goes back to being solid. Okay, so the only way that that can be perpendicular to that plane is if it's perpendicular to every line that's in that plane. Now obviously I cannot draw an infinite number of lines, but I can draw a couple more to illustrate the idea. So for instance, if this was a line in the plane, then this would have to be perpendicular here. And if I draw another line, these lines would also have to be perpendicular. So you have to kind of imagine it because we're drawing a 2D picture that represents 3 dimensions, but this would be how you would draw that figure. And that's all I have for you today. Thank you for watching the video.